Hello all, welcome to the H3A Bionet Introduction to Bioinformatics course. It's an online module. I'm Jonathan Kayondo from the Uganda Virus Research Institute. I'll be facilitating this module on sequence alignment theory and application. This is an introductory session. In this session, we shall learn about various applications of sequence alignment, concepts of homology in its various forms, evolutionary perspective of sequence alignment, pairwise sequence alignment, and sequence alignment approaches. It is my expectation that hopefully you shall come away with a good grasp of sequence alignment basics. So, what is sequence alignment? Sequence alignment is a way of arranging two or more sequences to identify regions of similar character patterns that could be as a result of functional, structural, or evolutionary relationships between the sequences. We search for series of identical or similar character patterns between the two sequences. Alignment could include mismatches or gaps for non-identical character patterns or alignments. An alignment can be made between any two sequences. Why do sequence alignment? Well, for various reasons. It's done to predict the function of a protein or a gene. It's done to predict the molecular structure. It can be done as a first step for phylogenetic analysis during analysis of evolutionary relationships. Sequences that are very much alike probably have the same function. They have similar secondary and tertiary structure if they happen to be proteins, and shared ancestral sequence, though not always. Sequence alignment enables the following: annotation of new sequences, modeling of protein structures, and phylogenetic analysis. For many biologists, the existence of an underlying force behind biological processes, including observed sequence similarities, is always at the back of their minds. One goal of sequence alignment is to enable the researcher determine whether homology inference that can be observed from shared sequence similarity can be justified. Obviously, homology has to do with shared ancestry. The mechanisms by which sequences evolve and diverge from a common ancestor include substitutions, deletions, and insertion. Now that we have clarified homology, let us step back and identify some other sequence relationship terminology: identity versus similarity. Although these terms can be interchanged in popular usage, they are not the same. Identity means exactly the same character in the same position, whereas similarity includes having to do with similar chemical properties or characteristics. Similarity is a quantifiable property. Two sequences are similar if the order of their characters is recognizably the same and they can be aligned. We have said that similarity can be quantified. A snag comes in when trying to decipher how similar is very similar to infer homology. As a cutoff or a standard, your sequence needs to be at least more than 100 residues to be convincingly assessed in this manner. If it happens to be a protein, to call it homology, you require about 25% amino acid identity. For nucleotide identity, the bar is a bit higher. 70% and above will be required to call a gene homologous. However, homology or non-homology is more than just sequence similarity. However, in reality, things are not as straightforward as that though. For example, some proteins whose amino acid identity is less than 15% have the same tertiary structures, whereas others that have up to 20% amino acid identity have different 3D structures. Also, don't forget that things could be similar due to convergent evolution. Therefore, in order to really ascertain homology, also consider other things, such as the expectation value, length of the segments similar between the two sequences, the patterns of the amino acid that are conserved, and the number of insertions and deletions. Note that for nucleotides, identity and similarity are synonymous and they can be interchanged in this situation. For example, in this figure, you have nucleotide substitutions that involve or share roughly the same basic characteristics, but they are really not